Consider a quantum particle in a one-dimensional box of length L. The coordinate of the leftmost wall of the box is at x equal to 0, and that of rightmost wall is x equal to L. Okay, particle in a box from 0 to L. Particle in a box from 0 to L. Is that okay? Speak up. The particle is in the ground state at t equal to 0. Okay, so psi is initial state. Let me write initial state. Okay, that's equal to ground state root of 2 by L sine pi x by L. That's the ground state wave function. Okay, at t equal to 0, suddenly change the length of the box to 3L, moving the right wall. Okay, now this right wall is changed to L to suddenly change the length of the box to 3L. Okay, that means 1L, 2L, 3L. Is that okay? By moving the right wall, what is the probability that a particle is in the ground state of the new system immediately after the change? Is that okay? Now this is the initial state or state before measurement. Can I say like this? State before the measurement. What he's asking is what is the probability of finding it in the ground state of the new box? Am I right? What is the ground state of new box? Psi after measurement, isn't it? So can I say like, if you do again, now you are doing the measurement on this system, not this system. You should get outcome of this one. Energy eigenvalue of this one. Am I right? It's asking what is the probability of getting ground state. Am I right? Ground state means again E1 state of new box. Okay, let me call this as old. This old box is a new box. Okay, so that's nothing but what is psi 1 of new? Is equal to root of 2 by 3L sine pi x by 3L. Am I right? Pick up. If you want to find the probability of this one, okay, so now the state after the measurement is this one. Am I right? Pick up. That's why this is the final state. State after the measurement. This is a state before measurement. Am I right? Or let me write initial state. Initial state. This is a final state. Okay. Initial state, final state, inner product, mod square. When you take inner product, you have to take 0 to 3L as your region of integral. But this wave function is 0 outside 0 to L. Is that okay? That means this function is like this. Am I right? This function is like this. Am I right? You are taking the product of those two functions. That means only this limit will remain. Am I right? So that's why s equal to 0 to L will remain. Okay. This should also be normalized. This should also be normalized. Initial state, final state, both should be normalized. Is that okay? Speak up. So 0 to L, root of 2 by L, root of 2 by 3L. Okay. Sine pi x by L into sine pi x by 3L, isn't it? Mod square dx mod square. Speak up. Can you do this one? I think this is a just question. Just question. Okay. Probability of E1 new, that's equal to final state, initial state. Let me write it here. Okay. So final state is root of 2 by, or let me write the final state. Root of 2 by 3L sine pi x by 3L. This is a final state. Okay. Initial state, root of 2 by L sine pi x by L dx. Final state, initial state, inner product, mod square. In the inner product, you have to take integral over full region of interest 0 to 3L, but this function, okay, initial state is 0 outside that one, outside 0 to L. Okay, that's why the limit turns out to be 0 to L. When you take a product, the product is 0 in this region, isn't it? This wave function is 0 here. Is that okay? 0 here. Speak up. 1 by 2 phi. I can take 3 by 2 outside. Am I right? 3 by 2 outside. What is this one? 3 plus 1 by 2 again. 3 by 2 outside, 1 plus 1 by 2. Now it's right. Am I right? 9 by 8 pi mod square. I'm feeling that it should be that option 3, isn't it? 81 by 64 pi square. Psi of x is equal to a e power minus b square x square by 2, isn't it? Is normalized eigenfunction of a Schrodinger equation and energy E in one-dimensional potential. V of x equal to 0 at x equal to 0. Which one of the following is correct? It's given energy and potential. Now look at here. Compare it with ground state of harmonic oscillator. E power minus m omega by 2 h bar x square. Okay. Then b square is nothing but m omega by h bar. Speak up. B square. So for this kind of ground state, what is the potential? V is equal to half m omega square into x square, isn't it? Speak up. M omega is equal to h bar b square, isn't it? M omega square is equal to h bar square b power 4. M omega square, that's equal to 1 by m into h bar square b power 4. Am I right? Speak up. Is equal to half, because m omega square I have to write in terms of b, isn't it? Speak up. So that's why that's equal to 1 by m h bar square b power 4. Am I right? So or I can write as h bar again x square I forgot. Okay, x square. This x square. That's equal to h bar square b power 4 divided by 2m into x square. Okay. So your ground state energy, am I right? E naught h bar omega by 2. Speak up. So how do you get h bar omega here? Or just solve it for omega. Better to solve it for omega. Am I right? Omega is equal to h bar b square by m. Am I right? H bar b square by m, isn't it? So it's equal to h bar by 2. Omega is equal to h bar b square by m. That's equal to h bar square b square by 2m. Speak up. H bar square b square by 2m you don't have, but h bar square b power 4 by 2m into x square you have. Option B. No. Again, which of the following is correct? That's the question. Either potential or energy, whatever. Okay. I mean, you find both. Okay. By comparing it with actual ground state of what do you call quantum harmonic oscillator. Okay. One-dimensional quantum harmonic oscillator. Is that okay? Speak up. I hope we have done the similar problem yesterday. Yeah. Is that okay? Actually, what he is expecting is you have to substitute this potential into Schrodinger equation, okay, and applying this boundary condition v of x equal to 0 at x equal to 0, that condition, applying that condition, and find the energy and potential. That's possible actually, okay, but need not be done in that way. Is that okay? Speak up. Do it in your way. Look at here. I did like this, isn't it? Later I found that I could have solved it for omega and substitute everything for omega, isn't it? Speak up. Mass and h bar will not change. What is the difference? That's the difference is omega. Am I right? Speak up. Omega is a characteristic of that spring constant or something. Am I right? You can say like this. I think another question on expansion. Particle of mass m contained in one-dimensional infinite square well from x equal to minus L by 2 to plus L by 2. Particle is in the ground state, okay? The walls of the box move to minus L to plus L. What is the probability that particle will be in the ground state after the sudden expansion? It is non-zero, I can say like this. Am I right? Why? Ground state is a cosine function only, isn't it? After the expansion also it is a symmetric well, okay? Ground state of expanded box is also, I mean, cosine into cosine. I mean, limit is symmetrical here, okay? That's why we can explore the evenness and oddness. If suppose if I ask what is the probability of getting first exerted state of new box, First exact state of new box is sine function, am I right? Symmetric box. Initial state is cosine function. Inner product. No. Whatever half region merges, your limit is symmetrical. Odd function. Limit is symmetrical. Think about function. You need to do the integral, am I right? Speak up. Are you getting point? I mean, look at here. The initial state, let me write initial state. That's equal to root of 2 by L sine cos pi x by L. Am I right? I better write like this when x is between minus L by 2 to plus L by 2. Am I right? Okay. 0 otherwise. Okay. That's the initial state. So now box is expanded. Okay. Your new state will be your new state will be root of 2 by L 2 by 2L. Am I right? The length of the box is minus L to plus L. The length of the box is 2L now. 1 by minus L by 2 to plus L by 2, length of the box is L. Okay. So cos n pi x by 2L. Okay. N equal to 135, isn't it? So root of 2 by 2L sine n pi x by 2L. Okay. Where n is equal to 2, 4, 6, and so on. Am I right? Pick up. Now the idea is, okay, the idea is writing the initial state in terms of this one, expanding this one in terms of this one. Actually, the state on which we are doing the measurement. Just recall my words. Okay, should be expanded as a eigenstate of measurement operator. Am I right? Measurement operator, energy measurement here. Okay, usually energy eigenstate of the new system, isn't it? Speak up. Then you need to find Cn. Now again, our region is symmetric. Am I right? This is symmetric function. Am I right? This is even function. When you expand even function in terms of cosine and sine, again sine coefficient will be 0. Am I right? Just recall your Fourier analysis, isn't it? Speak up. Or if you think of initial state, final state, inner product mod square, isn't it? When you take inner product between this one and this one, it is 0. Limit you need to take minus L by 2 to plus L by 2 because this is 0 outside minus L by 2 to plus L by 2. So this region, these function have the region x is between minus L to plus L. Am I right? Speak up. But this function is 0 outside. Your limit is minus L by 2 to plus L by 2. That's a symmetric limit. Am I right? Symmetric about 0. Is that okay? So that's why you get probability of getting ground state is there. Probability of getting second exact state is there. Probability of getting first exact state is 0. Without solving, we should be able to argue. Speak up. Are you getting this one? The state, we have a sudden expansion. When there is a sudden expansion, this state is momentarily unchanged. Is that okay? It is moved suddenly. Though that this state is unchanged, but it is not eigenstate now. In the new box on which you are doing the measurement, it's not eigenstate. It should be written in terms of eigenstate. Then coefficient will talk about probability amplitude, isn't it? Speak up. So again, if I want to give very graphical idea, okay, so minus L to plus L, okay, minus L by 2 to plus L by 2, okay. Your ground state is like this, okay. This is the initial state. Earlier box was like this. You suddenly expanded. So that wave function is unchanged. Okay, that's why he said sudden expansion. Now, so this one should be expanded in terms of this function minus L by 2 to plus L by 2. This initial state should be expanded in terms of Cn into psi n nu. I mean, because these are also complete. Am I right? Energy eigenstates are complete. Am I right? Any function can be written in terms of them, isn't it? Speak up. But when you expand this one, look at here, you should take your region of interest becomes only minus L by 2 to plus L by 2 because other region, this psi I itself is 0. Okay. That's why, how do you find Cn? Cn is nothing but integral of psi n nu star psi I dx. Am I right? If you take the limit, okay, again, you take the limit of psi and nu minus L to plus L, but psi I is 0 outside this one. That's why limit will be minus L by 2 to plus L by 2. Limit will turns out to be minus L by 2 to plus L by 2, isn't it? Even if you take minus L to plus L, because whenever you take inner product, you have to take all the region of interest. Am I right? So here, this much region is our region of interest. But this psi I is 0 outside minus L by 2 to plus L by 2. So that's how it turns out to be. Look at here, minus L by 2 to plus L by 2. Okay. Psi n nu into psi I dx. Am I right? Ideas are the same. Okay. So, and probability of getting some psi n nu roughly, or probability of getting En actually, isn't it? En nu. That's equal to mod Cn square. That's what I told. Initial state, final state, inner product mod square. Is that okay? Final state means state after the measurement should be one of the eigenstate of the what you call new box. Am I right? Speak up. That's the final state. Initial state, inner product mod square. Okay? Speak up. Can you do this one? Again, cos A, cos B formula. Is that it? Cos pi x by L. I think cos pi x by 3L. Sorry, 2L. Practice that integral. Practice some trigonometry also. You have to tell me this answer without solving the question. Consider the two lowest normalized eigenfunctions psi naught and psi 1 of a one-dimensional system. They satisfy psi naught equal to psi naught star, psi 1 is equal to alpha d psi naught by dx. Okay. That means ground state is even, real function. Okay. Ground state is a real function. First excited state is also a real function, because when you take derivative, you will not get any complex quantity, isn't it? Pick up. And alpha is also real. The expectation value of momentum operator in psi 1. Minus I h bar psi 1 star dou psi 1 by dou x dx. Am I right? Speak up. He said solve without why 0? Expectation value cannot be imaginary, but psi 1 is real. It should be real. If it is non-zero, it is real. Okay, if it is non-zero, the whole quantity will become imaginary, isn't it? Expectation value cannot be imaginary, it should be 0. Or maybe if you just substitute everything, if you do, you will get the same thing. Are you getting it? If you write psi 1 in terms of psi naught, and if you do that one, you will get the same thing, but try to explore the logic. Okay, it can't be non-zero. It can't be non-zero, because if this integral exists, it will be imaginary. If this integral exists and if it is non-zero, the quantity will be imaginary. That is not possible physically. Okay. Harmonic oscillator. Read the question carefully. Okay, because understanding the question is halfway to solve the problem. Speaker. Okay. Understanding whatever they are communicating, that's very important. Okay. Two harmonic oscillator A and B are in the excited eigenstate. Okay, with the same excitation energy as measured from the respective ground state energies. Is that okay? So that means, if suppose, so this is the ground state, half h bar omega A. Okay, this is the ground state, half h bar omega B. This is system B. This is system A. Is that okay? Now, what they are saying, their excitation energies are same, measured from the respective ground state. That means this is excited by an energy E. Okay, it's also excited by an energy, same energy E. Are you getting a point? They are in the excited state. This also one eigenstate where it is now. Okay, so now this state I will call it as Na plus half h bar omega A. Okay, this state energy, let me write Nb plus half h bar omega B. Okay, speak up. They are in the same excitation energy. Okay, they are in the excited state with the same excitation energy. I mean, from ground state they are at the same energy energy difference from their state and ground state are same. Speak up. So that means, look at here, what he's trying to say here is Na plus half, okay, h bar omega A minus half h bar omega A. Am I right? That's this equal to E. That's equal to Nb plus half h bar omega B minus half h bar omega B. Am I right? Speak up. That means Na h bar omega A is equal to Nb h bar omega B, isn't it? So that's what he's saying, okay? He's saying this one. Now, look at that one. The natural frequency of A is twice that of B. Omega A is twice that of B. Substitute and find the relation between Na and Nb. First, read the question fully. So I don't have full screenshot here, okay? Speak up. I have just started solving the problem because I read this question already, but you read the question properly and proceed, okay? Speak up. So omega is equal to twice of omega B. So just substitute, that's equal to Na h bar 2 omega B is equal to Nb h bar omega B. So 2 Na, can I write it here? Speak up. 2 times Na is equal to Nb. He has given this one. That okay? I mean, by all this sentence, what he has given? 2 Na is equal to Nb, or Na is equal to Nb by 2. Quantum number of A is equal to quantum number of B by 2. Is that okay? Speak up. Now look at here. He has given the wave function of B is sketched here. Okay? Wave function of B is sketched here. Now, what is Nb? By seeing wave function of B, this is a wave function of B. Can you tell me what is Nb? Speak up. Number of nodes. This is not a node. Okay, it will slowly touch to infinity. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nb is equal to 10. Nb is equal to 10. Isn't it? Speak up. And what is Na now? Nb by 2, that's equal to 5. Isn't it? He has given wave function of B. He's asking what is the best representation of wave function of A. Wave function of A should contain 5 nodes. Isn't it? Number of nodes. Now, options are like this. What are the options which contain 5 nodes? This contain more than 5 nodes. This contain 1, 2, 3, 4, 5, 6, 7. 7 nodes. You can rule out option C and D. Option A and B are possible. Which one you choose? Option A extends from minus 10 to plus 10. I hope you can't see this one. Okay, this is minus 10, this is plus 10. This is minus 10, this is plus 10, this is minus 5, this is plus 5. Okay, see the earlier curve. Let me draw this one. This is minus 5 to plus 5. Okay, it is like this actually. 5, okay, like this. 5 are there. You think like that. Is that okay? So that this is what you call psi B, okay, psi and B. You have to plot psi and A. Don't forget, frequency of A is twice of frequency of B. He has mentioned. Now, in the option again, wave function of B that extends between minus 5 to plus 5 roughly. Am I right? You can see here. So can you see this one? Minus 5 to plus 5. Minus 5 to plus 5, isn't it? So now that's why, again, can you guess what should be the wave function of A? Whether it is minus 10 to plus 10 or whether it's between minus 5 to plus 5. Either option A or B, both has 5 nodes, okay? Pick up. Frequency of A is more than frequency of B. So you have a Gaussian function with the Harmonic polynomial. Do you remember that Gaussian function is e power minus m omega by 2 h bar into x square? Am I right? All states contain this one. This is a common factor. Am I right? So here comes the omega. If omega is more, this Gaussian will try to die the curve. Try to what you call that curve will diode quickly, am I right? If this coefficient is more, isn't it? Speak up. So that's why. Which one you choose? Option B. Why? Because frequency of A is more than frequency of B. Am I right? In the excited state, it extends from -5 to +5. B extends from -5 to +5. Am I right? In the NB is equal to 10 state. Am I right? 10 state, isn't it? Now, one thing is this is a lower state, okay, of A, and other one is its frequency is double that one of B, isn't it? If frequency is higher, this will become a little bit narrower, isn't it? Become. Or this Gaussian will try to make it more narrower, isn't it? Gaussian function is making it to touch to 0, isn't it? Harmonic polynomial into Gaussian, isn't it? Speak up. That's why since omega is high here, it should die out more quickly than this curve. Am I right? I mean, you can think like that. That's why it should be well within -5 to +5. Is that okay? Actually, you can take Harmonic polynomial roots and you can judge actually. Okay, but that's quite lengthy. Try to make it simple. Am I right? Harmonic polynomial roots means you will get these points actually, isn't it? Points where it is touching the 0. But that's not suggestible. Okay, finding the root and checking whether roots are extending like this or not, that's not suggestible. Okay, you just think in this way. Since omega is higher because of this Gaussian, okay, which comes because of the Gaussian, again it will die out more quickly than system B. Is that okay? Speak up.